today is day 4 of Unit 4. We're going to talk about how do we solve problems involving exponential growth and decay. So in day 3's lesson, we did talk a little bit about this. So today what we're going to talk about is we have these two, I won't call them new equations, but they're a little new. So we have our original exponential equation, which is y equals ab raised to the x power. A is the initial amount, or the y-intercept. Not or, it is both, but we either call it the initial amount if we're talking about word problem, or if we're just talking about the graph, that is our y-intercept. B is the base. This is our growth and decay factor. And x is our exponent. Remember, if it is an exponential function, there should be an x in the exponent. So when we're talking about word problem, x is going to represent the number of years. So remember that I said years as we go through today and day 5's lesson. So the new thing that we're going to talk about is, instead of just having a b, where we look at the table and we see how much we're multiplying by as we go up, we're going to look at b standing for 1 plus r or 1 minus r. Okay? If we're adding, it's going to be growth. If we are subtracting, it's going to be a decay. So when you see the letter r, this represents a rate as a decimal. Okay? So what I mean by this is, as we go through this, you're going to see that we're going to talk about increasing rate of certain percentages. Well, remember, when we have percentages, we don't ever refer to our percentages, or we don't ever multiply by a percent. We always have to turn it to a decimal. So keep that in mind as we go through this lesson. All right, so example number 1. So since 1995, the daily cost of patient care in community hospitals in the United States has increased. Okay, so increased, we know it's going to be a growth, about 4% per year. Okay, so in 1995, such hospital costs were an average of $968 per day. Okay, so let's bring that out right now. Okay. So the first thing we know, this is going to be growth because it's increasing. This is going to be our A value right here because 1995 is our initial year. Okay. All right. So write an equation to model. Now notice I said equation, so we're going to have a y equals. Okay. When I say function, that's when you have to do f of x. Okay, so write an equation to model the cost of hospital care. So the first thing, I always like you to write down the formulas. A lot of you have been doing that, so great job. So this one is going to be 1 plus r raised to the x power. Okay, so we're just going to simply put these in. One thing I'll do on the side, make sure you write 4% is equal to 0.04. Okay, be careful with that. This will be 968, and then 1 plus 0.04. And raised to the x power. Okay, so there's our answer for A. Now we want to use our equation to estimate the cost per day in 2010. Now, 2010 is not going to be our year. We have to figure out what the years are. So what we're going to do over on the side, okay, so we're going to say x equals, we don't know, okay, so we're going to say 2010 minus 1995, okay, so that's going to be 5 years, okay, so x equals, 15. So x equals 15 years. So now what we're going to do is we are going to substitute. Okay, please make sure you are trying this in your calculator to make sure you can correctly put it into your calculator. And again, this is probably an easy mistake you can do by getting this one wrong, putting it in your calculator incorrectly. So please make sure you are practicing. Okay? So after I put this in, I get about $1,743.31. Make sure that you guys pay attention to what we're talking about. We're talking about money, so you're always going to round to the nearest hundredth. Okay? And there's the answer for number 1. Okay, number 2. Daniel's print shop purchased a new printer for $35,000. Okay. So I'm going to guess that that's A. Each year it depreciates. Please pay attention to these words. Okay, if you don't know what depreciates means, that means that it goes down. Okay, I did write that down. At a rate of 5%. So R equals 5%, which equals 0.05. What will be its approximate value by the end of the 4th year? So X equals 4. So first, and of course round to the nearest cent. Okay, so first we are going to write our equation. So always rewrite this. Okay, so Y equals, so we got 35,000, 1 minus 0.05, and we are going to raise to the 4th power. Okay? So just to show you why this is, I mean if you haven't noticed already, so remember our B value, if it's a decay, is always going to be less than 1. If you actually do the math, it is less than 1. If you look back at question number 1, that one we added, so that was higher. That was greater than. So that's times growth. So $28,507.72. Okay. So I would accept this. You could also write, you know, after 4 years, the car depreciates. $28,000. Losing it. Okay. So the nice thing about these, if you think back to maybe like middle school, so when you did a middle school question like this, I mean, of course we would word it a little bit, you know, easier, but when you did a middle school question like this, you would just multiply 35,000 by the rate, so 0.05. You'd get a number, and then you'd subtract it from $35,000. So you would see the percentage that it would be like tax, right? So you find the tax and you add it. Well, this equation right here eliminates having 2 steps. Okay, so everything is all in one nice equation for us. Okay. All right, let's go to the next one. In 2000, Florida's population was 16 million. So that's going to be A. Since 2000, the state's population has grown. Okay, that's going to be growth, 2% each year. Okay, find Florida's population after 6 months. So this should be a red flag right here because it says months. Okay, so X. Let's see. Oh, I guess we're gonna. So what we're going to do is we need to make this years. So we know that there are 12 years, 12 months in a year. So we're going to make our exponent. Unfortunately, we're going to make it an exponent, a fraction. So when you put this into your calculator, I'll write down the whole equation, but when you put this in your calculator, please make sure when you raise it, so you hit your caret button, make sure you put the 6/12 in parentheses. Okay, so y equals a 1 plus r raised to the x. Okay. Alright, so we get 16 million. That would be 6 zeros. Okay. R is equal to 2%, which is equal to 0.02. And then we raise it to 6/12. Okay, so if you do this, you will get 16 million 159,207.9. So approximately 16,159,208 people. Okay, so after those 6 months, that's what we would have. Alright, question number 4. Suppose your parents deposited $1,500 in an account paying 3.5 interest. Okay, compounded annually. So annually means once a year. We want to find the account balance after 18 years. So this is A. R equals 3.5%, which is equal to 0.035. And X equals 18. Okay. So let's try it out. So Y equals A, let's see. So this is going to be growth, because interest. Okay, so it's going up. All right, let's see. 1 plus R raised to the x power. So Y is equal to 1,500. 1 plus 0.05 raised to the 18th power. Okay, so throw that all in your calculator, and you will get $2,786.23. Okay, I'm going to do number 5 with you, and then I'm going to let you do 6 and 7 by yourselves. Okay, the air pressure inside Jason's bike tires decreases by about 3% each year. The original pressure was 55 pounds per square inch. What is the tire pressure after 9 months? Okay, so this is a decay. R is equal to 3%, which is equal to 0.03. A is equal to 55, and X, remember this has to be in years, so it's going to be 9/12. Now I'm going to show you in the calculator as well. Okay, so Y equals A 1 plus r raised to the x power equals 55. 1 plus. Okay. So if we put this into our calculator, we would get 53.7578. Okay, so approximately 54 psi. Okay, so really quick, I'm just going to show you how to do that in the calculator. And I'll show you in both calculators. Alright, so let's see. So we had 55, so you can literally just type all this right in. Times 1 minus 0.03. And then when you hit the caret button, now mine automatically goes up. So this, if you have a calculator like this, that's what this would look like. Okay. So see, you got what I would get. Now if you have this calculator, you would do, okay, again, 55 times 1 minus 0.3. And then when you hit the caret button, if you have anything more than one thing, you're going to have to put it in parentheses. So 9 divided by 12. So you see you get the same thing. Please make sure you know your own calculator. I understand that you guys use mine here, but unfortunately, so I highly recommend you guys, number one, bringing your own if you have it. Number two, you really should be trying to take the same calculator every time, so that when you get to a test, you don't know, or you know how to do with that exact calculator. So go ahead and try 6 and 7 for classwork. If you do not get done with it for class, then please do it for homework.